All right, and we are live. Hello, everybody. Welcome to the stream. Yeah, it has been a little bit since we've actually streamed. That's because work has picked back up, which is good. But it also means we have slightly less time to work on scripting stuff. But on the plus side, we have scripting stuff working. So, we don't need to, theoretically, we don't need to work in as, large segments of time anymore because we got through a lot of, the hard stuff. However, I'm now realizing something. Now that we do have, the, core of the scripting system working, we're able to generate a function, and that function compiles and it runs. And there's still a fair amount of work still needed to be done there, but it's all adding on to the foundation we already have. We have nothing, it's working. We know it's working, it's fast, we have control flow working. The only things that we haven't gotten working are being able to pass structures and enums by value into functions, casting, which is super easy. We do have to add stuff to the IR to actually be able to do that, to cast between different types and whatnot. So there's still structural changes that need to be added in to everything. Mainly just function calls, figuring out how I'm doing function calls, and yeah, all of that. But aside from just going further on the technical side of things for the scripting language, because that's all just kind of busy work, there's not a ton of problem solving to be done there. Aside from deciding how I'm going to do function signatures, that might be difficult, because I need to. One very important part of the scripting language is it needs to be cross-platform and easily embeddable into anything. I want BraneScript to be something that other people can use, especially since, in a month or so, I want to do a YouTube video that's just I made the fastest scripting language. And when you do a video like that, and it's hopefully not clickbait, people are going to want to use it. So I would want it to be at least loosely usable at that point when I do publish a video about it. It needs to be if you want to throw this into your game engine, you can. Should you do that? Probably not. Not at this point. It's probably good to wait a couple more years for it to actually mature and stabilize, but I want it to be usable for that. I guess I need to do templates too is the other thing I haven't done yet. Fully implement templates. Because we have the syntax for templates, and we're able to use templates for intrinsic functions. But we're not able to use templates for actual, structure and function creation quite yet. But all of that is less. All of this is just we implement templates, we make an actual allocator, design how we. This is what we need to work on here. Designing how we dispatch pipelines, how we schedule threads. I've decided I'm going to add in hot reload from the very beginning. I want you to be able to change what's going on in the editor on the fly, especially since I want to use BraneScript for all of the UI of the editor. Even if I still haven't decided if the editor is a separate binary or embedded into the client. In either case, I want to use BraneScript to actually code the UI of the editor. And for that to work, I do not want to write UI in a system that doesn't have hot reloading. It's that would be madness. I don't want like compiling Rust. I don't like I don't subscribe to like the compiling Rust is so slow. You compile it once, everything's cached. It compiles fast after that. But wouldn't that depend on whether you want in-game editor or not? What do you mean? Like if the editor is embedded in the client? It might depend on that, but it's kind of the idea of it's a lot easier to make an editor that isn't embedded into the game client. And even if I do eventually want an in-game editor, it might make sense to still write a like standalone editor before eventually writing an in-game editor. Though the same could be said, like it might be overall easier to just start with an editor in the client because that will force me to develop all the systems of the engine to the point where you can write an entire game engine editor inside of the engine itself. But the problem is like that delays being able to do stuff for the first time really far. Um, it's like how much work do you want to do up front and how much work do you want to do later? I am at this point leaning towards in-engine editor because it just seems like the smarter, less tech debt way to do stuff. It's going to be a lot of work though. Anyways, so that's why I want hot reload is because I want to write the editor of the engine in the engine. Just keep everything consistent, you know? But now that means, we need to have an engine good enough to write the editor of the engine in it. Okay. But all of that kind of to lead up to what are we doing this stream? You'll notice in the title of the stream. So let me refresh the Twitch window just so I can make sure that oh, 1 second. Okay, Twitch is updated now for the actual name of the stream. We were benchmarking the scripting language last stream. If you want to see if you want to see a benchmark of my scripting language, you can have it. So I'll just run that real quickly since I did have it labeled as benchmarking the custom scripting language at first. But yeah, what we're working on this stream is not necessarily the scripting language, though if we go long enough, we will start working on the scripting language. But before I go any further on it, what I need to decide is what paradigm am I using for the game engine? What does it actually look like? Because like there's like an entity component system, there's game object based, that is kind of like object oriented, or do we want to go with a node system like Godot has, or do we want to invent something completely different? Okay, so there's our benchmark. 100 million nested loop iterations takes 117 milliseconds. For reference, JavaScript takes like 180 to do the same. So, scripting language faster than JavaScript. Yippee! But yeah, so yeah, Twitch, there's your profiling of the scripting language. But yeah, so last night I couldn't sleep last night, so I just broke out Notion and started actually writing all this down because I'm kind of like mentally blocked. There's some things I do know I still need to do with the scripting language, but what I'm not sure how. Running out of free blocks. What is a free block? Anyways, maybe it's like block of text. I don't know. But Yeah, so last night I just went through and I started trying to figure out what what is Brain's like how does Brain script interact with the engine, because from the very start the idea of Brain Engine was like, if we want to have native level performance of stuff and runtime loading of things and they all like interact in this one soup, how do you get all of that to work together in a in very quickly and in a coherent manner, or not quickly but efficiently. Quickly sounds like you're coding fast, not well. But yeah, so basically I just started writing out my thoughts, and that's what we're going to continue to do on this stream. Is I left off on runtime level interfaces, but let me kind of read through what I have so far so that we're kind of all on the same page of where the design is currently at. So, the Brane runtime. So this isn't necessarily Brane engine. The Brane runtime is a part of Brane script, and then the engine is going to be built off of the Brane runtime, which is part of the Brane script runtime. So basically, the core of Brane engine isn't in Brane engine; it's actually in Brane script. So, how does the brains work? Now that we have code generation, we need to actually run the code we've generated. This means passing data, scheduling, and getting data back from it. Pipelines. So the core of like Brane engine is, and Brane script, is this concept of pipelines, which figured out what I'm kind of labeling this as is multi-threaded time sliced work, basically. Because before, I've been good about saying that Brane script is multi-threaded by default, but the time sliced portion of this, like, that's what I was getting at with pipelines, is that they're inherently time sliced. Everything is a coroutine. Most things shouldn't need to complete in a same frame, in the same frame that they start. So I have this whole like blurb about like Brane is built for VR, and in VR like a single frame drop or stutter is unacceptable. Because for like a little bit of background, like when I like super overwork myself, my left eye starts twitching, and I don't mean the eyelid twitches, I mean the actual eye itself starts like looking where I don't want it to, very briefly, and just kind of twitching. So in like that state, like if you're in a headset and that like starts happening, it's like, is the graphics glitching out, or is it like, am I glitching out, or is the headset glitching out? So I've kind of set it as a goal that to build Brane Engine around the concept of never ever having a frame stutter or dropping frames, and I don't think that's too crazy of an idea. If you build the entire engine around it, that is. So that is from this point forward, that is the main goal of the Brane Engine. And I mean, I've said it as like no loading screens was the original way I said it, but I think a more all-encompassing like goal is no frame stutters ever, never dropping a frame, and I would include loading screens in that. Basically, the game never stops running. The experience never stops running. And that's the core goal of where we're going with this engine. And the way we're going to go about that is basically having the engine be able to profile itself for every single aspect. Every single aspect of the engine is able to profile itself. So, of course, like there's the obvious things like CPU time and GPU time. Those are like the obvious thing obvious things that people profile first and are the easiest to profile, but there's other things. And those other things can be represented in CPU or GPU time if you have blocking operations waiting on them. But there's also a lot of things that I don't know if a lot of people account for in actual engine design, and they probably do. Like, it was the entire marketing of, like, the PS5 was it the PS4 or the PS5? I think it was the PS5. They're like, oh, it has an SSD, so we don't need to have loading screens anymore because we have so much disk I/O bandwidth. But yeah, so I think an important part of the engine is we profile how much compute bandwidth we have, and we also compute how much I/O bandwidth we have. So that's like, how much data are we transferring in between the GPU and the CPU? How much data are we transferring between RAM and the disk? Which I don't think is going to be that much. I don't think we're going to have too much problems with disk bandwidth since we're not loading games off of disk. But also profiling network bandwidth as well. Like, how much data is getting sent to and from the server, and that includes VoIP, that includes so voice over IP, like voice chat, that includes downloading assets from the server, and that includes real-time data, and that's usually like 3 categories of data, and VoIP and real-time data are kind of like the same data type, but a lot of times you put them on different servers, because voice data is just like, it's hard to make less of that, and it's a constant load. And it's also something that it's really easy to horizontally scale across a bunch of servers. But yeah, that's something to figure out when we get to it. But the general idea I have is, like, if you're in a multiplayer lobby and you have, like, people running around, but you also have assets you still need to download. Like, let's say somebody has, like, a 2 terabyte avatar, and they switch into that avatar, and suddenly you can't see anything that's happening in the lobby anymore because you're too busy downloading this asset with all of your network bandwidth. Now, you could potentially fix that problem by having the engine runtime itself be aware of how much network bandwidth it actually has to work with, and going like, oh, this particular bit of network traffic here needs to always be reliable. So we'll scale the stuff that can scale, like downloading assets from a server. We'll scale that just up to the point where it starts to where it would slow down the other bandwidth that we want to prioritize. Now, are routers technically supposed to do that? Yes. Like, that's there's a lot of networking bandwidth to be able to prioritize traffic and whatnot. This would kind of just be like less so I guess for balancing of network bandwidth, and more so like a not exceeding the total cap of network bandwidth. Because if you're requesting too much network traffic, that just, like, it slows stuff down. Like, if you've ever downloaded a game while also playing a game, you know it absolutely kills the performance of the game itself. And maybe there's ways to correctly configure routers to actually be able to handle that, but I want a runtime level solution for that sort of deal. But then on the compute side of things, since we must always be able to render a frame in time to display it, that means we must be able to guarantee that a frame blocking operation never occurs. So never in our engine code do we ever we'll basically just what I said. Like, there can't ever be a thing that stops a frame from being rendered. Just nothing. And the tools we'll use to do that is everything's multi-threaded, everything is time sliceable, and we also will profile it as it's time sliced. So basically, you do as many slices of time until you actually run out of time. And I actually saw a Twitter post from a game studio recently that was releasing an asset for, I believe, either Unreal or Unity. It looked like Unreal. I think it was Unreal. And they made an asset that does exactly that. And I was like, hey, that's an idea I've had for years. Of course, it's like, it doesn't matter because I haven't written it yet. So, like, good for them having the same idea. And it also looked like it worked pretty well. So I'm like, cool, it's a good idea. I felt like validated. But yeah, now it's my turn to actually make that. But yeah. And then I have something here about how Brane script is like functional without side effects, or like each segment of a pipeline doesn't have side effects, if that makes sense. It doesn't mutate any global state. It doesn't. Brane scripts don't affect anything until they return control back over to the runtime, and that's something that I need to figure out how that system works before I can actually make pipelines exist, because the purpose of a pipeline is to affect the runtime, but I need to figure out what interfaces it uses to do that. Wonder if this will end up like Minecraft server hosting, where there will be a bunch of third-party hosts with rentable headless servers that can be connected to. That's actually exactly what I'm going for. And it's like slightly inspired by that. Yeah, Brane Engine is just Minecraft. The children yearn for the mines. At least that's the server hosting paradigm that I'm going for. Like, if you want to spin up a server for you and your friends, you can do that. You're the binaries, go do that. Not necessarily like free, but like it's free for you to set up yourself and pay for your own servers. Yeah. And you probably will be able to LAN host things. In fact, I think that will be required, especially when you're developing worlds. Because I think the way that the way it's currently looking like I'm going to make the editor is that the editor itself is going to be multiplayer. Because if the way I make the editor is by having the editor exist in the actual client, what I want to do is make it so it's a special mode that the asset server switches into that changes the way the world is expressed in such a way that you can edit it. Paradigm like that is the way you want it to work, right? Similar to like Minecraft servers where everybody's kind of hosting their own and you type in an IP address to actually get there at first. Pretty much, yes. And eventually I do think there will be the equivalent of search engines. Like have an index of this domain or these IPs are these worlds, and here's like the references between them. Like I do think there will be worlds specifically just for indexing and finding other worlds. And that's something that I'm going to try to build myself. I don't really expect it to just pop up. But the paradigm of people hosting their own servers and it working like Minecraft servers, that is how I imagine it working, exactly. But yeah, for the actual editor, the absolute ideal version of the editor is that it's a built-in mode of asset and runtime servers to switch into a mode where if this is like a special type of asset server, you have something like a source-controlled repository of assets, and those assets are stored server-side. Now, You don't need to edit through a server. You could run the server locally on your machine, so it's like turn on development server on your local machine. And then you boot up the Brane client and remote into the local host at like editor instance of the asset server. And instead of like serving you the regular world, it would serve you an editor with the assets for your world in there. And that is how I imagine the ideal version of the Brane Engine editor working at this point. The problem is that takes a lot of work. Like, so much work. And that's the only reason I'm considering still doing a standalone editor like I currently have, is because lots of work. Hopefully we'll have a Brane Engine version of the Mirai botnet that started off some team wanting to DDoS competitors' server hosting service. That sounds interesting. Competitors' Minecraft server hosting. So was there like a Minecraft server plugin that was like DDoSing a different set of Minecraft servers or something like that? Got so big there was a worry it would take down the internet. That is amazing. All I'll say is there's nothing I can do to stop that from happening, because the unlike Minecraft, my server binaries are going to be open source. So there might be more of a risk of that. But it's kind of I can't stop that because it's like open source. People can do whatever they want with it. But anyways, yeah, basically scripts are going to be, instead of in a Brane script, you calling a function and that function like doing things. Instead, whenever you run a Brane script pipeline segment, it constructs lists. It will construct lists of commands, and those lists of commands will get passed to the actual runtime, and then those commands will be executed. And that's basically how it's either it passes commands to the runtime, or it transforms data and then passes the transformed data. So if, let's say this is an entity component system, and we pass in like a list of transforms, and inside the pipeline, you do whatever transformations you need to do to the transforms, and then you get that data back. And that's like the easiest form of a pipeline. But if the pipeline actually needs to affect the state of the program, then it needs to return something akin to like a command buffer. And that's how, yeah. I think a big detail was that it exploited some obscure JavaScript vulnerability that nobody had seen before then. Nice. 0 days. 0 days are fun. It was probably Java, because Minecraft is written in Java, not JavaScript. It'd be really funny if it was JavaScript, though. But yeah, basically, the reason why I'm like going the command buffer approach is, if code threatens to block the main loop, I want to be able to just kill threads, like kill scripts. Send a signal to a thread that makes it just halt whatever it's doing and then restart itself. And this should really only pop up in debug mode, because all of like pipelines are like will be super time sliced. So if your script segment, like a segment of your script, takes more than, say, a fourth of a second, or like half of a frame's total compute time, just like kill it. And then there will be like the ability for longer running script segments in anything that doesn't block frames. So you could have like a background job that takes a lot longer. But for anything that the frame is actively waiting on, then yeah, it like a core part of like our thing is you don't block the frame. You just never block the frame. If you do an infinite while loop, it just gets killed. And then we move on to just rendering a frame. It wasn't Minecraft directly, it was one of the tools needed for server hosting. Nice. Thank you for the compliment on the lighting. I was like, yeah, we'll just go straight Cyberpunk this time. But I got lazy. I could have set up the other light here, but no, gonna just go full Cyberpunk. Because like if I wanted to go full Cyberpunk, sorry, you have squirreled me. If I wanted to go full Cyberpunk, if I got a blue light, no, like that, and then just like toned it down a bit, then like that's like super Cyberpunk. Maybe one tick. There we go. That is super Cyberpunk. Really messes with your eyes though. There we go. We're good. But yeah. That's kind of the philosophy behind pipelines themselves, but okay, cool. We have this pipelines concept and we have a way to program them. Now what do they do? How do they interact with everything else going on? And that's where I have this vague idea of events and data dependent on certain events. So if I think about this, um, let's say we have like a start frame event, and then start frame event kicks off like a lot of jobs, and then maybe this job runs for like multiple frames, but let's say this is when like we need the data for a frame to be rendered. So we have like some frame blocking operations here, and frame blocking operations are basically just anything that the frame requires data from before we're actually able to render a frame. And like of course this job just runs, maybe like something else runs. We have like a couple other frame loops here, and then before we render this frame, it gets like the data from that pipeline somehow affects the state and gets merged into the scene state or whatnot, and then it affects that frame, but it doesn't affect the frame up until that point. Random question. I was thinking about using linear regression as a sorting algorithm. Get min, max, num index, and fit the array. Stupid, crazy, or crazy awesome. I don't know enough to tell. I'm going to be completely honest. I don't know math terms. Give me a second. Ah, I see. The machine learning algorithm. I'm aware of this. My favorite book has an entire chapter on this. Sure, go for it. It might work. It might be crazy good. Or it might not be. But yeah, so this is like this is the vague idea that I'm this is the vague idea I'm working with for how the how the actual loop of the engine works. But the problem is I don't know how to construct this graph here. How do we decide this thing depends on this thing, which depends on these two things. Because let's say we're like a user generated content engine, right? Which means at any moment we might add more content into the scene here, and now suddenly the graph also needs to take into account this thing, and it needs to connect up, and it might need to interact with other systems in very particular ways. Like this new system here might need to inject itself in between this pipeline here to properly function. But how do we actually like model that? How does a freshly loaded Brane script tell everything, hey, this is where I should be put into the entire pipeline? Like, just how do we handle that at all? And I haven't quite figured it out yet. Okay. Yeah, and that's kind of like the whole thing I go through here. Like, we know how data gets processed, but how do we decide what to process and when? And the thing that I kind of came up with last night was generally the way we think about the frame loop of a game engine is we have a loop, and then everything I want to do everything in that loop as fast as possible, and then at the end of like doing everything in there as fast as possible, we have output that we output to a frame, and then we just restart, and we basically just the loop itself is driving everything that happens. So if we imagine this is our if we imagine this is our while loop, while not while the thing is not closed, we just keep going around, and then we dispatch this function, and then this function, then this function, and then every single one of these is like a busy wait. Like everything must be done. Sounds similar to language and ends. Not sure what and ends stands for there. Perhaps looking into a random forest algorithm. That sounds like machine learning stuff. Neural network? Similar to languages, neural network. Not currently planning on any machine learning stuff for this whole thing. This needs to be very deterministic. In fact, that's the problem, is that we need to make this deterministic. But basically the distinction I want to make here is traditionally the loop of a game engine is the loop itself is what's driving everything that happens in a scene. So even when you time slice stuff in Unity, for instance, like in Unity, you'd have like not pre-update, but just like you would have like update, and then you would have late. Like you call update on every single object in the scene, and then you call late update on every object in the scene, and it also walks the graph of your scene in a very deterministic manner. I should have shaved before streaming. This is bugging me. Um, but Yeah, so we have a late update, and then somewhere in here we have like the physics update that happens either here or here, and it might sometimes happen, it might sometimes not happen. What are you doing? Also, we don't see it. I mean, I can see it in the camera, so it's like it's bothering me because I can see it. So what we're designing right now is the actual runtime for the game engine. Like we have the start of a scripting language, but to finish out the scripting language, we need to know exactly how it's going to be used. And the main thing I'm trying to figure out is how we schedule stuff and connect stuff up. And in a traditional game engine, it's driven by the while loop, and we have distinct stages of events, basically. We do the update event on everything. We do the late update event on everything. Yes, indeed, the fun part. And then at the very end of this, we actually render everything. But here's the thing. This works extremely well for a single thread. But the instant you start adding extra threads in there, you run into, like, here's our coroutines update somewhere in here. And this is Unity's time slicing system, is coroutines, or the job system. And they don't happen anywhere in the loop, but those jobs are dispatched from these lock to the loop updates, and also like we join them from the lock to the loop updates. And I'm trying to figure out if I can create a generic system that isn't necessarily super tied to a loop. And what I would absolutely love is if people could specifically is if people could specifically work with me here, Brane, is if people could specifically not determine, not say, define? Yeah. Specifically define what not only the data dependencies of their scripts are, but also, I'm going to use this word, temporal dependencies of their scripts. So, what data do I need to be done before I write this script, and what other scripts need to come before this one? So that's kind of just like script dependency, but temporal sounds cool because, temporal, time, wibbly wobbly, timey wimey, crossing the dimensions. Yeah. So the idea that I came up with is, this is like the traditional game engine. Just try to do everything in the loop. And if everything in the loop takes too long, then the loop takes too long. But what if we flip this around and go, okay, but what is the purpose of a loop? The purpose of the loop is, I want a visual frame I can see every 6.9 milliseconds, which I'm not making this up. That is how much time budget you have if you want to hit 144 frames. So 6.9, or actually, clear, 1,000 milliseconds divided by 6.9. There's your 144 frames. Indeed. But basically, yeah, game engines need the question that's being asked, the operation that's happening is, in this amount of time, I want this data. Less so than this generic, like, do everything. Instead, it is a question of, like, if I never want to drop a single frame, I must always have this data in this amount of time consistently. So, our system needs to be built around the idea of setting a deadline for when I want data. Yeah. And that's kind of like, I don't know that if I've ever seen a game engine or really any system implemented around this idea of like explicitly saying, instead of just doing it as fast as possible, instead it's a give it to me exactly at this time. Or I want this thing on exactly this amount of time. Generally, if you want to lock the frame rate of a runtime to something, what you do is you do everything as fast as possible, and then you just busy wait until the deadline. There's probably a reason for that. No. The reason is nobody's thought of anything else. And the other reason is it's easy, it's intuitive, and it's just the way that everything works. There's like an evolution to, you can see exactly why it's built that way, but I don't think there's a convincing reason why the idea that we're trying to come up with now hasn't been done before, aside from the fact that it is complicated. But yeah, then the runtime can focus on delivering a result within that slice of time, and also you have the ability to optionally do work within that time. So, if all the major operations that I need to do in a frame only take 3 milliseconds if I only take 3 milliseconds to get everything done, guess what? I now know that I have 3 milliseconds to do other things, which is amazing. And then I can just use that. I can use that compute for whatever I want. And 7 milliseconds is an extreme case. Like, that is explicitly 144. That's basically the highest refresh rate you're going to get on any headset. This is called buffering, right? Like, in graphic settings of video games, you can render frames in advance or something like that. Not necessarily. So what you're thinking of is every time I render, I then send that render off and then restart this loop, but this render hasn't finished. It hasn't actually been displayed to the screen yet. And it doesn't get displayed to the screen until, like, this is the CPU here. This while loop is the CPU. The render gets dispatched to the GPU. And the frame only gets actually displayed once it's ready. But it's not necessarily, yeah. Let's see, frame buffer. Yeah, frame buffering is something different than we're talking about now. Though we will be able to do frame buffering through this thing. What are you doing? Sorry, I wasn't paying attention. Are you making like an async game update sort of thing? Kind of like that. Basically, with the Brane script concept of pipelines, everything is time sliced and multi-threadable by default. So I'm trying to figure out a runtime that supports that well, as opposed to like your traditional call update on everything system. Instead, I want like a way to create a graph of like what data needs to be executed when, what pipelines need to be executed when, and what are their dependencies, and how does all of the data flow through the system. But yeah. And currently the idea that I'm thinking of is instead of a while loop, instead of like a deterministic like this graph here was my like initial idea for how all of this will work. And it's kind of like this while loop. And then this block here, this would be an update event. Oh, interesting. If you press control, you actually, or is that right click? It might be right click. Does right click erase? That's actually huge if true. Yeah, right click erases. That's going to make my life a lot easier. Anyways. Yeah, this is an update event. And then everything kind of gets spawned off of that update event. And then this would be like the render event. And the weird thing about this particular setup is that render has multiple dependencies. So if we went with this like forward-driven approach, then the problem we run into is render needs both of these paths of data to complete before we do whatever is awaiting on render, which would be like dispatching stuff to the GPU and then everything else that happens there. But if we like stick with this system, then it's like super unclear of it is super unclear how we actually make this wait on everything it needs. How do we know everything it needs and whatnot? But if we reverse this around, is it scala draw or use the boxes? No, we're gonna draw boxes manually because I have a stylus and a drawing tablet, and I don't want to have to deal with it. I think there's some Rust engine project I saw a while ago that did something like that. Are you making the rendering loop completely decoupled from the update graph then? Not necessarily, but I do actually have a friend working on a completely decoupled rendering loop. I do think it makes sense to have at least some things tightly coupled to the actual rendering loop, because I think if your rendering gets out of step with actual if like I'm rendering frames at this rate and then I'm updating my scene at this rate, I run into the potential problem of, well, actually, let's say we have a CPU heavy load and we're updating the scene at less of a rate than rendering. Suddenly, you just saw 2 frames of the exact same data, and then you see like consistent updates, and then you see all of a sudden again 2 frames of the exact same data, and that's going to look like stuttering. I also don't really see a reason why rendering needs to be decoupled from the core loop, but I do see a reason to have almost everything not in the core loop itself. So stuff like physics, that's core to the that should probably be, or at least like any code to do with moving things should be tied to the core loop. Physics, the first example I came up with, I'm not sure if that should be tied to the core loop, because physics like can take longer than a single frame, and that's always dangerous when that does happen. But rendering loop completely decoupled from the update graph. The rendering loop is part of the update graph. Anyways, so this is like the initial idea was this, but now the idea that I'm going with is, what if instead of doing fire the update event and then eventually we know that like this event gets propagated down this path, this event gets propagated down this path, And then when render gets an event from this path and an event from this path, then render will fire. That doesn't make sense to me. But what does make sense to me is what if we have a render like operation or dependency. We want the data, or no, we have a render request. Not necessarily a render request. Maybe let's call this a scene data request. And what this block represents is all of the data required to render a scene for a specific frame. Now, the scene data request, probably just like this, is aware of all of the data that it needs to pull to actually render a scene. So, instead of having this where update is what's driving all of the operations to occur, instead we say, hey, I would like to render a frame 7 milliseconds from now. And then that is your request for scene data. I want all of my scene data in 6 milliseconds from now. And the reason why we have that actual 6 milliseconds is specifically for time slicing. So basically we could have something like, maybe we have this particular system in an entity, or this particular system in a chunk, and we say, hey, I want the data from your chunk to be able to render what's inside of it. And then this is the budget of time I'm giving you to give me that data. And then it goes, okay, cool. And it runs as much operations as it can to update stuff in that time, and then returns the requested data back. And maybe this chunk here, it's entirely possible that it might require more data than it currently has. So then you get like a branching tree of data dependencies. Or it might need to fire off other things, like maybe in this update request, it figures out that during the time of this frame, it figures out that during the time of this frame, or soon, we'll need to load something. Then it can fire off a multi-frame request for data, and then eventually get that data back at some point, and work with that. But that's kind of like separate from the update loop. That's kind of like that is technically a side effect of requests. But I do think the generic request concept is a lot more powerful, because instead of we have this update event, and the update event must eventually make it to the render event, and if that chain gets broken anywhere, the entire system breaks, we don't render a frame. Or I don't know, there's a counter or something that's don't take data from the source if it doesn't complete in time. I don't know. I am dying. But if instead it's the other direction of us wanting to render stuff and requesting data in a certain amount of time, I think that makes a lot more sense for this system. And then instead of it being suddenly our custom pipelines need to subscribe to the update event and also subscribe or tell the renderer that the renderer needs to wait until they're done processing stuff. Instead, it can just say, hey, scene data, I have more scene data to give you. Ask me for my scene data at the correct time. And that is all of the connective tissue that needs to get put together there. So I think this is our paradigm for how we schedule stuff in a frame. And this is completely decoupled from basically all frame related things. Like, there is no main thread in the system outside of like stuff like certain graphics APIs require stuff to be called from the same thread. So yes, we do need to have the ability to have a main thread for certain IO operations. In fact, I think it makes sense to keep at least one thread per IO operation. So that's like one thread for graphics, one thread for audio, for instance, for rendering audio, and maybe another thread for input. If the renderer requests the data, but the update can't fulfill certain aspect in time, you end up with the same problem you mentioned. If some data is not available, it'll just be rendered. Yes, it doesn't solve that problem. The problem that I was trying to solve was specifically the point of if I'm driving updates from an event and then another event requires the results of that event to finish for that to render. Basically, imagine this right here is just never connected up. Like, I forget to connect this pipeline here to this pipeline here. Like, let's say this event, inside of this event, there's like a callback, and calling that callback schedules this pipeline. And then it's this pipeline's job to schedule this pipeline. And what if it never schedules that pipeline because I forgot to set it up? And then that flag on the renderer saying that this pipeline is done never gets set because the pipeline was never even called in the first place. It's not that an error occurred, it was just set up wrong. Whereas if we go from this direction, then the renderer goes, hey, pipeline, do things. And the pipeline goes, okay, I'm going to ask this pipeline for stuff. And then this asks whatever its dependencies are for stuff. This still has the potential that there would be errors, but if we have the pattern of like, this pipeline has error handling for if this pipeline doesn't occur, or it doesn't, like, returns an error. Of course, we do need to have error handling for all that, but we don't have the problem of there being an error because nothing happened. It will always be an error because something went wrong, as opposed to an error where nothing happened. Let's see, do you think that there's any chance that all the cross-threads syncing and similar results in slower performance at the end of all this anyway? Probably depends on the use case. Overall runtime performance, I think, yes, there is a solid chance that for any scene where there's not a lot of data that can be processed in parallel, then yeah, it could make stuff slower if there's a lot of like serial data dependencies. Yeah, but if you forget the connection, still you end up with the same exact problem. No, you don't. You don't. Because if this pipeline never requests data from this pipeline, it doesn't wait on it. It just returns. So no, I don't end up with the same problem because we're talking about a time dependency, not a data dependency. Let's see. I think I will look up that botnet at some point. That does sound interesting. But yeah. So I think that method of scheduling stuff makes more sense because instead of having to connect our code up at 2 points, instead we just have to connect it up at 1 point. And if this user script wants data from this other user script, there's not really a way around. There isn't really a way around needing to come up with a system specifically for this pipeline to define that it has a data dependency on that pipeline. There's not really a way around that. But instead of having to declare stuff ahead of time for that, we can do it after the fact, which is a lot easier. But yeah, so basically the main revelation from all of this is the direction this stuff is driven from is the thing. It's not driven from a loop. It's not it's not driven from a loop doing timed sequences of events. Because while this works and it is intuitive, you run into errors where stuff happens out of the order that you expect it to, and that's a problem. And with this, there's the potential for misconfiguration, which is also a problem. With this, much less chance of... We can abstract away a lot of the stuff that causes misconfigurations, but we still need to figure out how do we actually configure stuff. But yeah, return valid request for data within the allotted time frame. And those requests can set off other requests that affect their state. And yeah, all that sort of stuff. Allow us to have multiple frames in flight at once. And at the end of the day, this does leave us with two important questions, which are: how do we decide what needs to be done to render a frame? Like, what actually gets done when we load a new user script? How does that get added to the graph of things that need to be called? How do we let user-generated content inject itself into the pipeline? And how do we allow systems authored by different people to seamlessly interact with each other? And just like we need to come up with a good abstraction for communication between different stuff. And the thing I'm most worried about isn't your scripts talking to the engine. That's fairly easy to deal with. And yep, that's what we're talking about. Hooks, messages, how do things talk to each other, stuff. But the problem that I am trying to solve isn't how does your script talk to the engine itself, because the engine interface will be designed well and it will be ergonomic, and I will do an amazing job doing that, of course. But what about when your scripts are talking to other people's scripts? Like, what if, say, you want to have a combat system and multiple avatars need to interact with this combat system? What you need is a common way for all of those things to interact with each other. You're probably going to have a series of different events that need to happen in certain orders for them all to work together properly. Just like, how does all of that work correctly? And right now, the thing that I'm seeing a lot in a lot of user-generated content systems is basically the actor model. So for those unfamiliar, the actor model is what the Beam runtime, Erlang, and Elixir use. That's the most famous example. I think AppScript not AppScript. That's like a JavaScript thing. There's like some language that the creator of C++ created after the fact that was like the actor model. And it's not actors as in Unreal Engine actors. The idea is that in your system, in a decentralized system, you have actors. And this is like what a lot of websites use for their backend because it's very horizontally scalable. But if you have actor A and actor B, these two actors, they have code inside them that runs, they're single threaded, but the thing that happens on the Beam virtual machine, since Elixir is the one I'm most familiar with, I haven't used it, but I've done some research, by which I mean I've asked ChatGPT for code examples and had it explain it to me, and also listened to a lot of conference talks on it, which of course is the way that you learn about languages, not actually using them. Uh, but basically, you have these two actors, and these actors, the only way that they can communicate with each other is by sending messages to each other, like little blips of information structured in certain ways. And by dumbing down how they communicate to just that level, you can do a lot of things. These two actors could be running on the same machine. They could be running on completely different machines, and the messages could be transmitted over a network. You can't tell. You can't tell if these are in the same process within the same computer. You can't tell if they're on different processes inside the same computer. And you can't tell if they're communicating over the cloud. This is a cloud. It's entirely abstracted away what actually happens. Now, how efficient is this? There's like overhead, because now like you have to serialize every single time you want stuff to talk to each other. Like there's a serialization step, or I guess it's dynamically typed, so you can just send objects to and forth and only do the serialization step. If you actually do need to send it over a network, as opposed to, yeah, pinging them can tell you, no. Well, if you measure how much time it takes from them to respond, then maybe, yes, that could tell you. But the way that you actually send messages to other actors on on Elixir, or like in the Beam virtual machine, is there's the send function, and then you have an address of an actor, and then you send in your data. And this is the only way for your actors to communicate. This is the only function you have access to. And this address is a GUID, so it's random hexadecimal string. And that's all you have. That's all you know about the other actor. That's the only interface you have. And then to actually get data back, you just call receive. I'm going to spell this wrong, because I'd never know where the I goes. RECIEV? I don't know. Anyway, you type out the word receive, and then you pattern match on your output, and that, because it's functional, it's very nice. And then you do whatever you want with that particular message that you got from there. And it's actually cool because you can handle messages. The message, when the machine gets messages, it stores them in a first in, first out queue, but you can handle different message types out of order. So if you have a queue of like a ton of messages A, a ton of messages B, and a ton of messages of type C, and those are all like mixed together, So it's like maybe it's A, C, B, A, B, B, A, and like that's your list of things. You could just go receive A, receive A, receive A, receive A, receive A, and then receive B, receive B, receive B, and it keeps them in order, which is super interesting. Thank you. But yeah, you do receive, which I guess is how I tried spelling it first. But yeah, then you do receive, and then you do like a pattern matching statement to decide what things you want to receive. And that's how the Elixir and Beam virtual machine work. And this is an incredibly fault-tolerant system, not because nothing can go wrong, but if something does go wrong, it just kills the actor and restarts it. Which I don't necessarily feel comfortable with that form of error handling, but it is extremely fault-tolerant because your servers are never down. If anything, you just lose a little bit of data because they restarted. Yeah, so that is the actor model. Now, this is the actor model in its purest form, and I don't think we're going to steal the actor model in its purest form, though I think we're going to take inspiration from it. So, when I said that when dealing with user-generated content systems, we deal a lot with actor model style things, if you look at VRChat Udon, and no, don't worry. We're already significantly faster than the Udon VM, so don't worry. I'm not actually taking inspiration from Udon. I'm detecting a pattern. And also, Horizon Worlds network event. Give me the actual... We'll go with broadcast events. And yes, I have built stuff on Horizon Worlds, and I am currently building stuff on Horizon Worlds. So, well, for a little bit of behind the scenes of like what is work that has picked up, as some of you are aware, me and my team won the recent VRChat. I guess not so recent anymore, but VRChat had a like Space World competition, and we got second place in that. And now we're gonna be trying to win some of Meta's hackathons as well. So we've learned we can make award-winning VRChat worlds. We've done that. Now we're trying to make award-winning Horizon worlds, which is a very different experience than working on VRChat. Because VRChat, you have fun and you make beautiful-looking worlds. And it's like for VRChat diehards, and then Horizon Worlds is it's Horizon Worlds. But yeah, basically, the pattern that I've seen between both of these and between other systems is both rely very heavily on events. So, in Meta Horizon, the way that you get basically any data from anything is through either listening to or receiving events. And yes, you can cast stuff to other things and directly access member variables because it's all TypeScript, but if you're not sure if a script is running on the server or the client, because Horizon Worlds has server authoritative scripting, you can run code directly on the server, which is something a lot of platforms are missing. That part is good. Now, however, you can't run local code and server code at the same time. They don't have like the ability to have an instance of an object run local code only and server code only, which makes you have a lot of problems. Like, oh no, now I need to spawn a prefab per player in my world that is running code locally on their machine, and that's the only way I can do that. I can't be like in Udon, where there's an instance of the same script running on each machine, and I can just have it act differently depending on ownership. It's like, I still have the script running, even if that player doesn't have ownership over that thing, so I can do like local compute to make it look prettier. Meta does not have that. It's like the server owns this object or a player owns this object. If a player owns the object, they can do actual script stuff on that, but nobody else can touch it, not even the server. So the cleanest way for everything to interact with each other is through events. That is the only way to send messages between each other. And this is how you get data out of the system. Now, Horizon Worlds used to be a VR-only editor, so this is kind of like a legacy thing. The way you get events from their native objects is through code block events, but then you can write your own local events and network events. So it's kind of a mess. But yeah, basically, you have entities in your scene, and they communicate by sending messages. That's basically what I was getting to with that point. Now, what about Udon? Udon explicitly doesn't actually have any way for Udon scripts to communicate to each other. The only thing they have is the ability to send events to each other. Now, is it clean? No. The way that member function calls work in Udon, and I know this because I wrote an Udon compiler, the way that they send data to other scripts on the same machine is there's two external function calls that you call. One of them is a function call that directly sets variables on the script that you're about to send an event to, and then you call a different extern to send an event to that Udon event, and then that Udon event runs, and instead of passing it function parameters, it just reads its own global variables and has a couple global variables mapped to being parameters to that function, which is like, anyways, and then like if that function returns things, after this external function call, you then would also actually, no. No, the external function call can't actually return data because it's a stack machine. It can actually return data, I think. I need to double check. The compiler I was writing was only the sender of events, not receiver of events. So I'm not sure how you get data back. It might be through also reading global variables. It might be that the Udon events can actually return data. I don't think Udon events can return data. So yeah, you would have to then check global variables to get data back. So it is not a clean pattern, but at the core of it, the only way things can communicate is through sending messages to each other, and they can send local events or network events. So here we go. 2 for 2, both of them communicate through not generic, but both of them communicate by sending events between objects. And that's how that works. So, and I guess, yes, you do have like Godot, where in Godot do you send events up and down the node tree? Godot is different because Godot is a native engine. You don't need to sandbox anything. And of course, they do have an event system, but anyways, it's probably not like that form of event. But So basically, I'm sitting here with, we have the actor model, which is the most beloved, and I will actually use the term beloved. People who use the actor model love the actor model, as opposed to people who use C++, which get stuck. They just have Stockholm syndrome. In the same way, how people get cultish about Rust, people can get cultish. Not, do they get cultish about the actor model? Actually, no. Actor model people seem relatively well adjusted. It might be more like the Ruby community. No, I wouldn't. Is that a disservice to the actor model people to say that they're like the Ruby community? The Ruby community is more well adjusted because they don't care about code; they just care about shipping stuff. They might have similarities to the Python community with the Python, Ruby, and Elixir give me the same vibes of their communities that care less about perfect code and more about shipping stuff. I very much care about perfect code and not as much about shipping stuff. But I don't tune it out. I'm listening. I hear the points that they have to say. I listened to a 6-hour long interview with like the inventor of Ruby on Rails, even though I disagreed with so much of the stuff coming out of his mouth. He did have some good points. A luxury language. I hate the concept of a luxury language so much. Anyways. So, basically, I want to come up with a version of the actor model that works in the context of user-generated data and isn't the slowest thing on Earth. That's what I'm getting to. I like the idea of things in our system sending events between each other. The one thing that I might add to the actor model... Here, 1 second. I must ban the viewer bot. The one thing that I don't necessarily like about the actor model is when you send a message, you can't necessarily wait on a response, if that makes sense. Now, I might be completely wrong. You might be able to receive and then pattern match on a specific sender of data to actually get the correct response for a particular request. It's also, actors are explicitly single-threaded. Like, an actor is, as far as you know, only runs on a single thread. Though, I'm actually not too sure about that, because I think the Beam virtual machine might time slice them and switch between different ones and whatnot. Like, I don't think receive is a actual threaded busy wait. I think when you do receive, it can switch off to other actors and whatnot. Anyway, Beam virtual machine efficient. Dynamically typed, so not efficient in the form of, like, JIT compiled speed, but efficient in the sense of it's very good at dealing with large amounts of tasks very well. So what we're working on here is our own version of the Beam virtual machine that is also efficient for data-intensive tasks and has as little bandwidth overhead, as little compute overhead for actually sending messages between things, because that's the main concern. So I have a number of concerns with the actor model that I should probably just write out here. The actor model, question mark. It's okay. I can control myself when I hear the word Python. The urge to like become rapid is it's there, but it is thoroughly suppressed. It is fine. I could pass the ganja bar test. We're good. Unless you say that you use Ruby because you can afford a luxury language. Then you know, like I might start tweaking out. What was I gonna do? Right. So the actor model pros. The come on. The ultimate form of encapsulation. Like just objectively, the actor model is the most encapsulated um system out there. You physically you don't even have the need for public and private functions because you just send messages and then it can decide whether or not it wants to respond to your messages. The encapsulation is at the logic level rather than like the grammar syntax level. Cons. It is the ultimate form of encapsulation. And we'll get back to that later. But other pros is very good for horizontal scaling. If I can spell that. Might need a director model where the actor models send too many complaints about their scripts. That's a good one. But yeah, ultimate form of encapsulation, very good for horizontal scaling. And this is a huge one. Um, it abstracts away networking. So if you want to do network API calls, it abstracts away networking. So this is like a huge positive. Like massive positive that it abstracts away networking. And that's I think that is something that I want to do is since Brane is going to be server authoritative and we have a very good UGC scripting language, um, we have obviously like an asset server, we have runtime servers, and then we have clients. And we have code running on all of these. And in the case of runtime servers or networking servers or whatever you want to call these, if you want to do rollback networking, which I kind of want to do, or basically if you need to call an API, like if you have an API key, you never want that touching the client. But in any game engine right now, if you use a pre-existing backend, like for instance, like Photon doesn't have any way for you to actually authenticate, like do any like secure logic. It just is able to network your users, and you have no like databases or whatnot. And there's other backends that do handle all that stuff. But anyways, you would in Brane be able to write a script that lives only on the server because it's like runtime loadable. You could have a generic runtime server that is able to load all the scripts required to be running the specific logic for one world or one chunk of a world. And I want the scripts on the server to be able to directly send messages to scripts running on the server, and then receive info back. So imagine if an RPC could have a return value. That's something that I want to work. When we'll finish the scripting language, though, when I figure out how I'm going to use the scripting language, the problem is I've gotten to the point where the scripting language is done enough that I need to know more about what I'm going to be using the scripting language for it to make sense to actually finish the scripting language. Because how do I finish it if I don't know what finished means? So that's what we're working on here. Is doing the design left that I need to do before I can finish the scripting language. Because we're at the point where we need to start writing the actual language runtime. And the language runtime is not even the language runtime, it's just the Brane runtime. It's not even the language runtime, it's what the game engine is going to be built on top of. Instead of being embedded in the game engine is going to be built on top of the actual language. Core language features. Not embedded, it is the foundation, not on top of the foundation. Oh! Here's the other thing. You want to know who else is doing the actor model? Epic. Epic is the other one that is doing the actor model. And this is like the thing that actually most sold me on it is Epic is literally getting one of like the main maintainers of Haskell to make their game scripting language, or to help design it, not actually implement it. I actually sent an email to him asking like some questions, and he was like not sure, because apparently he's not the one actually working on the runtime. He's just designing like the language syntax and how it functions. Which I'm like, but the runtime is the fun part. Anyways, so they have this concept of entities and then sending messages between entities. Be cool if you coded the language while in the environment, like a VR GUI based programming language. Oh my. So, the month before last, that was what I was working on, and then I realized it was going to take me like 5 months to actually get that to a point where it was working, and then we switched to making a C clone, and it's basically like 75% done already, as opposed to after the same period of time and having compiler macros working, and that was it. I had the type system working, and that was it. Speculative types. I was doing dependent typing, super functional programming. And I also did write a node graph. Basically, I have plans to eventually go back to that, but for the moment, we're just trying to get something working, because the same runtime that works for what we're working on now, like the runtime we're working on here, will also work for graphical stuff eventually. Theoretically, people could abstract and create other languages, and have them compile down to BraneScript IR in the same way WASM is kind of like a universal target, except less so for BraneScript, because we don't actually have a concept of a stack. Anyways, so I think coding in VR isn't actually that great unless the headset was comfortable enough. I'm going to get my hands on a big screen Beyond 2 fairly soon here. And I'm expecting that to be a lot better on the comfort side of things for coding in headset. In fact, it's basically going to be the first thing I try when I get my hands on the headset. Because sadly, Bradley actually, it was so funny. I like posted a picture on Twitter of like this theoretical desk setup where I have like a big screen Beyond and then like a 3D printed mount for a base station, and like put it on the desk right in front of me, and it's like be able to travel with that setup and whatnot. And he was like, "Hey, I have a base station that would work for that. You want it?" And I was like, "Sure." So I now have a modified base station that works better for close range. Uh, this is like modified by the Tundra Tracker team. I think is the ones who made that. Uh, but yeah, so I haven't been able to test it out yet because all I have is a original Vive that I have in storage. I've just been using the Quest 3 because it's a lot better. Um, yeah. Anyways, so verse, getting back to this, is a very interesting language. Um, because they have this concept of failure is control flow, and once you get out of failure contexts, it has this thing called speculative execution where code runs and it edits variables, and then if the code fails or errors, all of those changes you made to those variables um, gets rolled back. It gets erased. So it it's a very interesting paradigm that is like it's just weird. It's interesting. Made by one of the same like guys. It's like big in the Haskell project. Um, and it also like concurrency is at the language level, so you don't need to rely on system level threads. They have basically all of the same goals I do for my language, except for this weird speculative execution thing where I'm just kind of like, I don't know. That seems like this is like where I can definitely see the influence of Haskell on the way they're going about things, because functional programming languages have this concept that's not technically like, I don't think it's super like every functional language must have this, but most functional languages do have it, which is the concept of once you've defined a variable, that variable is now immutable. You can't change it. And this also applies to things like vectors and arrays. And so when you change a list in Haskell, for instance, like you add an element, it is basically you get a new vector with just that one element added, and it stores a reference to the old vector. Basically, lists are secretly like this tree-based data structure behind the scenes, and whenever you change aspects of the list, you're swapping out nodes of that tree instead of actually creating entirely new lists, because you always need to be able to refer back to old values as immutable. You can't actually edit any data in the past. So you're always creating new data and never editing stuff in place, which is very obviously not the most performant thing. And there's a lot of workarounds you do to make it more performant. And speculative execution, the way that they describe it here, kind of gives me the same vibes of you're able to change state, but it's still storing the old state. Now, it all depends on implementation details, right? Like, what does speculative execution actually mean? It's all implementation details, but initially, like, I am very, very suspicious of this. Also, where is it? Also, I'm so much a fan of statements and expressions being the same thing. I didn't do that in my language because I was lazy, and I think I might rewrite it at some point to make statements expressions as well. It was just a lot easier to parse with an actual nope, with an actual like definition of what a statement is. Go back. But somewhere in here, Anyway, the one thing I was looking for in here is it's also a garbage collected language. I'm very much also not a fan of garbage collection. We're going to have a semblance of garbage collection. We're going to have arena allocation is what we're going to do. So pointers in BraneScript are actual real pointers, but you don't have to worry about deallocating them. It's just the actual memory pages themselves are going to be reference counted. So every time you exit out of a pipeline stage, all the memory pages that it's no longer referencing, we will basically release the references to those memory pages. And if those memory pages have no more references, we put them back in the pool of memory pages to allocate from. Ability to do speculative execution within failure context. I think that just means the ability to do trial and error attempt to solve that error. No. This is like the core concept of the entire language. It's like the thing that they're experimenting around with. So this thing, failure, is control flow. So instead of true-false values, they don't have a concept of a Boolean. Actually, they probably do, but the way that you use a Boolean within an if statement is literally like you turn a Boolean into an exception. So when you have an if statement, you run an expression in the condition of the if statement, and if that condition throws an exception, it goes to the else statement. And the speculative execution is that failure context. So in the condition of an if statement is a failure context. So within the condition of an if statement, it's basically saying anything that happens inside of the condition here, if it fails, if we've changed the value of any local variables, we also roll those back. So that's what it means when it says the effects of the expression are committed if the expression succeeds. So if in the condition of an if statement, if it succeeds and it has also changed the value of local variables, then when you get to the step where it actually, if statement ends, it closes out, it succeeded, there's no longer a possibility that if statement could failed, then those changes you made to local variables are actually applied. And that's just kind of like my, so this basically means that you're either storing a snapshot of everything that could be edited before starting a failure context. So you literally just do a snapshot of all memory, or you do something where you don't actually set the values of variables. You have a variable that's when the scope gets dropped, then this is the variable that I want to set with this data, and whichever ones of those are still around, it just delays actually setting the variable till the end of the thing. Which is kind of you can write syntax that does that in other languages, and in fact it's the way you should do it in other languages, but it's a core part of the way that the verse scripting language works. And I just don't know, inside a failure context, is global state mutable? Because if global state is mutable inside of a failure context, that means you need to have the entirety of global context set up in such a way that you need to be able to roll back changes to it. If, you do a huge amount of operations and then failure happens and you have to roll all that back. So I have ideas of ways that speculative execution could work in this manner, but if you have any global state, it's just I don't know, or if you pass in large data structures, or yeah. But yeah, so switch statements, if statements, all of that, Actually, I don't know about switch statements. It might be match statements. Yeah, this rollback is both the coolest thing and the scariest thing about this language, but that's not, I don't really care about that. If it turns out people really like speculative execution in languages and there's an efficient way to implement that, I might consider that as a like contender for how I deal with like when I make a new version of Brane script that actually does all the fancy features that I want to instead of the MVP C style thing that I'm working on now. I might consider this as a language feature. However, I really like errors as return values. Like I really like that paradigm. Like enum based error handling is so clean and it's so intuitive, and you don't run into situations where you don't know why something has failed because you're always able to return specific data for specific failures. But basically, the main thing that I wanted to point out is VR chat, Meta Horizons, and Verse. Maybe not the Verse language itself, but Verse in the context of the editor is all some variation of the actor model, though for like Epic is the only one who has explicitly said Verse is the only one who has explicitly used the term actor model. And they have in like talks, I'm not seeing this on the page anywhere. Explicitly that they are using the actor model. And I believe the actor model is what they're going to use for different assets to communicate with each other. Because I'm not seeing message passing in the actual language itself yet. Actually, I'm going to keep that page open just so I have like all those different things. So basically, everybody's using some version of the actor model at some point. What version of the actor model works for the system that we're trying to create here? How does the actor model interact with the engine? How does the actor model work with user-generated scripts talking to other user-generated scripts? How do we deal with this? I really like the idea of having explicit runtime level interfaces, and I don't know if we'll directly call them interfaces, but like we might. But what I want to do is have there be a way to define, like, if you get a handle to something that you want to be able to communicate with through the actor style of message passing, and I want to add in the ability for explicit returns, because I don't want to have to create my own way to match up requests with the return values. I want very much the ability to make conversations between entities easy. We don't necessarily need the same level of fault tolerance of like with the beam. You don't necessarily need all your messages to go to the same client. In fact, that's how REST APIs generally work. Is they're completely stateless, and any one of your requests could theoretically be returned, like have a value returned by a different actor responding to it, as opposed to In the game dev sense, where you very much want specific recipients with specific states, and all of that sort of stuff. Where like state is very important. Come on, man. When you click on a Discord thing without actually seeing the text, and then it throws you into like the voice channel, and you're like, I didn't want to show myself there. So they just see like a misclick, bloop bloop. Because I have like the like preview text turned off on like phone notifications. I got. Okay, but yeah, there's a lot of developers UX stuff that I don't like about event systems, because you mistype the name of event, you mistype the name of an event, and suddenly like your code doesn't work, and you don't really have a way to statically verify that the event you're calling exists. I don't like that. And that's what these two systems have, is like with here in event best practices, they're going to say create a event container and then define what the definition for all of these events are. That way they're not like they're more statically typed. Like you're never saying like I want to test local event with these arguments. And this is a best practices, but here's the thing, it's not enforced to do this. It's like, hey, please do it this way. I'm not a fan of allowing people to foot gun themselves in ways that don't benefit them. Like, I'm fine with APIs being hard to figure out, if the hardness to figure out gives people benefit. There is no benefit for super dynamically typed event systems when you always know this is the event I want to send and this is the event that I want to receive. If that is always the case of it being static typing like that, I want static types. I don't like TypeScript or JavaScript. I don't like JavaScript. TypeScript is better, but it's like cursed to always be JavaScript. And then with Udon, like it is when you call a member function on another Udon sharp script, that is statically typed and checked. And then it's only dynamically typed on the runtime side of like when your function call gets abstracted into actually sending a custom event to that thing. But then when you do network events to stuff, then suddenly you're back to dynamically typing stuff. Like you have to actually write out the name of the function you want to send an event to, and that's we're back to the same thing. So it's like better for member function calls, because I think they were basically forced to make member function calls, or otherwise it would be completely unusable between the two. Because like you need to be able to do arguments between different so I like the pattern of event sending and sending messages, especially when you have a runtime level system for being able to get specific return values to specific messages, or validate the result of sending messages. I don't like the idea that I just send this off into the void and assume that it works. I want to be able to know that it worked, if that makes sense. And I don't like the contract of that back and forth being implicit I want that to be like a runtime level enforced thing. Because it's an extremely common pattern, and I just don't like it not being explicitly part of the, yeah. And like, if you do have something where you send an event and explicitly don't want any return value of like, did this work or not, then sure, that can be part of the interface that this returns void, returns nothing. But at some level, I still do want like a result of like, did this even send correctly? So, I like the patterns you can create with events. We need to be able to structure them better. And also, I'm gonna throw this into the actor model section, but the pattern is good. So we should use something like statically checked handles for sending messages using things like interfaces. And the other benefit of having actors or entities in scenes providing interfaces is a lot of times when you're listening for an event, you don't know if you correctly subscribed to an event, if that makes sense. So let's say I'm in Unity and I create a on collision enter event. The problem with that is there's a couple of requirements for that event to actually be like sent off. Like for that event to actually be triggered, there's the requirement for your scene to be configured properly. The entity that you have this script on needs to have a collider on it, so it needs to actually be collidable. You need to have a rigid body on that object, because the way it works in Unity is if you don't have a rigid body anywhere in the game object tree above it, the event gets sent directly to the same game object. But let's say you want to have colliders on objects that are children of your game object, and because like maybe you want to offset the colliders or rotate them, and rotating them is only really possible through parenting game objects. For that event to actually propagate up the tree properly, you at least need to set a kinematic rigid body on whatever that parent object is, so the events actually propagate upwards. And that is the only way. But in the script, they allow you to put a on collision enter event into just any script, and there's no way to tell is that event actually going to fire until it happens. Buys a concert ticket, shows up to the same venue, essentially. It's more like driving to the wrong address, maybe, or waiting at the same address, like trying to meet up with someone. They don't give you an address. You give them an address, or you don't even give them an address. You just kind of like assume where they're going to be, and then they also assume where you're going to be, and then they show up somewhere. It's just all around not very, like, events are an intuitive pattern. However, they aren't a very debuggable pattern. So, What I want to do is make a statically checked handles system where you get explicit interfaces for being able to communicate with other objects in the system. So, if you were to get a on collision, if you want to do a subscribe to an on collision interface, on collision event, the general pattern most game engines have is you have an entity, and then you see if this uh, has collider or rigid, and like sometimes you don't even check this. In the case of Horizon Worlds, you also don't check this. You just set up an event list, a codeblock event listener. This is like an example of what's halfway here. Okay, yeah. You do this connect code block event, and then you pass in the entity that you want to listen for events on. So this is like one step less abstracted than, say, Unity's event system. So with Unity, in my script, I go on collision enter, and then whatever script that is attached to just receives on collision enter events if they happen on that game object. But in Horizon Worlds, you don't just create a function and then it's magically called. Instead, you have one method that's magically called, the start method, which you're guaranteed this will always be called when the script is started. And then inside of start, you can say connect code block event. And one of the code block events is actually the update loop. And I'm actually a huge fan of this. Instead of update being a magically called function, instead it's an event that gets called every single frame that you listen to. I am a big fan of the way the event system is kind of architected in Horizons, when it works with its own rules, functions, and you don't have to debug it. And I don't have to work with Horizon Worlds. I like the idea of it, not the reality. But yeah, so the fun thing about this system of subscribing to events is that you can give it a target of which entity you want to target. So if in your component properties you have an entity property that shows up in the inspector, you could have one object or one script that has references to a ton of different colliders, and then you could just, for every single one of those properties, do connect code block event, and then instead of doing this dot entity, you could do this dot properties dot that collider, and you don't have to put the listener for an event in a script directly attached to that object. Instead, you can, from a script, decide where you are listening to something, which I really, really like. I really like the ability to decide where my code lives, because I don't like the structure of my code being dictated by the structure of the world. I like the structure of my code being dictated by my brain. So, ideally, the way that our runtime level interfaces works is we have a generic entity or actor, and I think actors or actions, I think we're going to have two different concepts, probably. We're probably going to have actors and actions. And I think our interfaces of actions. So we go from reference to obtain a runtime level to obtain an interface, or to interact with with different systems or to both listen and send events within this system. We want runtime and compile time checks to make sure that we are both not listening, or are only listening to events, or make sure that when we listen to events, they're actually valid. And when we send events, the receiver can actually hear them. What was the error? Computer, there were mixed messages. I've subscribed to a movie event that had my favorite actor and director models, but terminated at the wrong theater. Go. But yeah, so we'll have some workflow of going from a reference to an entity or actor, checking if they have the interface, we want, and potentially get a handle for that. It's basically like a try get function. Then use the handle as a static checked way to send messages or queue actions for the target of the handle. And that's pretty close to how I want things to interact, where we're essentially doing this, but with the benefit of, instead of messages being just pattern matched, instead we have an interface that this actor, before it sends a message to this actor or pipeline or whatever is executing can statically check, or it can do a runtime check to see if the receiver actually has the ability to respond to that type of message, and it has a statically checkable format for sending those messages. I just really like static checks for things because it makes it easy to refactor stuff. Oof. So now we know. Now we know that, like, for sure we're using some form of the actor model, um, but slightly defined differently. And I think it is fine if we call it the actor model instead of calling it something else. But with the caveat of actually for the actor model, does it matter how execution occurs? Because in my mind, it's been like is very much actor A and actor B are very explicitly running like on different threads, on different the execution context of this is entirely different of the execution context of this. And yes, from a code level and what you see as a programmer level, they are completely separate. They have no way to interact with each other except through messages, and they are completely separate things, no connection, conceptually. However, from the runtime level, the Beam virtual machine, if you have multiple actors running on the same machine, since this is a dynamically typed interpreted language, it probably does run different actors on the same thread, and there's no guarantee of like what thread this is running on, because by the nature of the extraction of the abstraction, it does not matter. So I can just say we're using the actor model because the way it's executed doesn't really matter. It's just the what people see. All right then, we'll go with it. Hello, how goes it? So I think yes. Actual behavior. Or that's good. It's always good to be good. Communication between different systems is abstracted and encapsulated through the through the actor model. Which means we are gonna have I'm gonna have to make a more I'm gonna have to make an easier to use syntax for pipelines. I don't want to have I explicitly don't want to have async. I don't want waiting on things to be an expression. It'll have to be a statement because I very much want. There's a footgun that JavaScript devs do a ton where they put async into a while loop. And then there's a bunch of things that could be done in parallel, and they iterate over the while loop, and let's like wait on this one item to finish. Wait on this one item to finish. Wait on this one item to finish. And an amazing example of this is let's take the masters of React themselves. And I'm going to show off, and this has been like this for months. Let me do. Oh joy. You can see it's like secretly a Horizons client but underneath the covers. Yeah, this is the word. Oh, did that audio glitch come through? Meta, everyone. Anyways, there's a bug in Meta Horizon Worlds. I'm not going to reopen the editor because I don't want to have to deal with it. Where if you take a bunch of entities and parent them to another entity, you can watch them like click, 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 click at about that speed, like bump, 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 one by one, see them parent themselves one at a time. When like, and I'm sitting here going like, is this making API calls to the server to move objects and awaiting the result of every single one of those parenting operations before dispatching the next one? Yeah. That's a instance of a resource that there's only one of and you're having to wait for the resource to free up. I'm talking about something where like how there's so many ways that you could optimize the the thing I'm talking about there where there's probably an async function in the editor that's like reparent object, and they did a for loop for selected item parent to new parent item, and is async, so they just async await every single one of those parent operations, and they just go one by one, chunk 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 chunk, and I can watch the editor reparent things one by one. So I did some like interesting like manual animation stuff. So I had like hierarchies of like hundreds of objects, and I had to mess with them manually because like the asset importing on Horizons isn't the best or most intuitive. So I was like manually reparenting hundreds of entities, and it was not fast. Anyways, basically, I have trauma from watching people use async incorrectly, so I'm not giving them async because I know that they will footgun it. And that's like, oh, if they're just using it correctly and it's a skill issue, then it's not actually the thing that's a problem, it's the programmers that is a problem. You know how slow every single modern website is nowadays because they like use React abstractions badly? It's like if if something is used incorrectly, not even like all of the time. Like let's just say like a solid 30% of the time where you see it in your everyday life, basically everywhere, and it's causing a problem for you in all of those places, then in my mind, it's less about it being like, oh, every single one of these developers needs to understand how to use this one feature better. For me, that's like, let's just create a different abstraction of this thing that makes them less prone to make that same mistake. Fix the problem not at the source, but like fix it before it can become a problem. So, all of that to say, I'm not going to give people async to await on things in pipelines. Instead, it's going to be an entire statement that it is harder for you to write, so you're more incentivized to put multiple things into the same await statement. I want to make it harder for you, like, make it. I want to make the efficient thing the thing that there is less friction to write. Like, it would take you more work to write the more efficient thing. Or no, it would take more effort to write the less efficient thing, so you just always write the efficient thing. Um, yeah. So that's the approach that we're gonna take for like. That's why I'm doing pipelines instead of async functions, because I want to like hammer in the concepts of how this works instead of being like, yeah, it's single threaded. Yeah. Instead, no, it's like this is a pipeline. It's not a function. It doesn't return back to the wherever it was called from. And yeah, different concept, easier to understand. Manipulative techniques so your engine works better. Not even so my engine works better, it's so that people have a better time coding on it. In the same way where like I've watched videos where people have responded to talks other people have given on things like the Rust borrow checker, and their argument, this is like a Jonathan Blow video responding to a video about Rust ECS. His argument he made in the video, which wasn't necessarily wrong, was that the code that person had written to make an entity component system wasn't necessarily good because of the borrow checker. It was because they had to abstract the code in such a way to where they basically circumvented the borrow checker by making something that the borrow checker couldn't check. But the result of doing that, they ended up with the same abstraction that a lot of engines end up with. And the reason that they solved the problem wasn't because they were actually solving the problem. It was because they were trying to solve the borrow checker. They weren't trying to solve the actual problem and thinking about all the different different implications of the system they were designing. They're like, no, I need to do this because the borrow checker needs it a certain way, instead of like, oh, it's an entity component system and the data can swap out from underneath you at any time, so you can't store a direct pointer reference because it can swap out from underneath you. Instead, they're just like, the borrow checker won't let me do it with a direct pointer, so I can't do it with a direct pointer. They got to the same result, but the way they got to the same result was because the abstraction of Rust forced them to not do it in the incorrect first thought way of doing that. And it's kind of like this, yeah, if you're a C programmer, you know what you're doing, you don't need the borrow checker. In the same way where if you know how async works, you don't need my abstraction of pipelines. But if you're somebody who has no clue what you're doing, using my abstraction that I'm working on of pipelines, you're going to have better code than naively using async, if that makes sense. Social engineering in programming is a thing. Python is social engineering because it's an easier language. That's all programming languages is. Otherwise, everybody would use C. It's different ways of framing the problem, and there's no way to frame the problem in a different way um, that runs less efficiently if you don't get some other benefit of the language being easier out of that. That's like the whole argument of Ruby is they like the creators of Ruby on Rails are like, yeah, we literally have like the slowest language, but we like the language, not the and like it even takes long to compile. It doesn't run fast. It doesn't compile fast, but it's fun. It's more ergonomic for them while they're actually in the code base, which I'm like, I care about the other two things. I don't care about how ergonomic the code is as I use it. I mean, I do, but like I find the faster coding languages ergonomic enough. Um, but yeah, it's kind of like emergently the design of a language can lead people to producing better results, more consistent results without fully understanding what's underneath it. And there's always going to be the argument of like, oh, if they understood the system better, they wouldn't need the abstraction. Um, yeah. Anyways, that's what I'm trying to do with async code. Is I'm trying to create an async abstraction that, yeah, if you know what you're doing, you could do it without the abstraction. But with the abstraction, there's just a lot less mental bandwidth. Okay, but I kind of have one last thing I need to figure out. Maybe not one last thing, but for this actor model, what is our definition of an actor? Because I'm not sure I want every visible entity. I'm not sure I want every single visible entity in my scene to be its own independent actor, if that makes sense. Especially since I want the ability for I like the design. I like the runtime benefits of entity component systems. So I'm immediately shying away from the concept of like, because the actor model is like, so there's entity component systems. There's just doing like, I wrote my game in C using Raylib, and that's probably like somewhat entity component system. It might be fast trucks, whatever. You kind of have like this. I made it in the easiest way. You have entity component systems over here with the most data oriented. You had it. I made it in the way that makes sense, which is kind of like here in the middle. Raylib, one vector for all of your different entity types. Fast truck, Casey Muratori esque design, and then you kind of have object oriented, which composition, object oriented composition. So you have the concept of game objects with components on them. So it looks like ECS, but it's actually object oriented. Data and behavior are stored in the same locations, and that's what Unity does. And then you have Unreal Engine, which is entirely like you have an actor. This is an object, and this actor is a C++ class. Even when you do a blueprint, it is inherited from a C++ class, and you can inherit from blueprints and just construct a tarball of like adding one tiny feature in each level of actor. But at the end of the day, you get one object. It's not a composition of components. It is like this is this static thing. It's unchanging. Um, very rigid. As opposed to like Unity, where you can construct game objects at runtime and create your structures and hierarchies. Through that, with Unreal is very much like this actor is an actor of this class, and you can't change that. It's just it exists as it is, and if you want to change the way it functions, you have to configure it through like variables and whatnot. But I don't know if at runtime, yeah, and then you go from like object oriented programming like that to then like actor model, where actors in Unreal Engine aren't actors in an actor model because they can still directly call C# functions on each other. There's not the level of abstraction that the actor model gives you there. And there's like global state and whatnot. Actors in Unreal Engine aren't actors in the actor model. They're two completely different concepts. They use the same word. So you go from object-oriented programming to the actor model. I cannot access public variables on anything. I have to get data by sending a message and then receiving a message back. Ultimate form of encapsulation there. The system, as the actor gathering messages together, the entities would send for more efficient message passing. So, I'm not quite sure what you're saying there, but I think you're somewhere on the same page as me, because that's kind of where, like, I'm not sure every visible object in my scene is an actor. I think I want to group it at a... I'm not sure I don't want to do game objects. I want it to be... I want this to be data... more entity component system-esque. Of you get lists of data and then you act on those lists of data. As opposed to more generic, like these things have member function calls. And I'm not quite sure what that looks like, because it kind of sounds like, when I say it like that, it kind of sounds like I want to do an entity component system. But here's the thing, if I think about something like a... If I think about something like an entity... Or... What am I even trying to say? If I think about something like a collider, there are instances where I want to know when that collider has collided with something, so I need a way to subscribe to an event specifically for that collider. Now, do I need to have one specific event fire off for every single time that specific collider is collided with? Or do I need to run a system or an actor that is the actor for a system that says, hey, to run this frame, I need the data of all the collisions that happened last frame. However, I would like to filter it down to these specific entities. But then you have the issue of your... how much computation is happening there? Because then you have like an instance of a thing where if there's like a bunch of like balls in a pit and they're all bouncing against each other, Then you have a system that wants just the collision for like avatar touching a button, for instance. And the button script only cares about that button. Then you run into a situation where it would be much more efficient just to fire off one singular callback for the button when that collision is detected, as opposed to like all of these collisions being filtered by the button script. Then again, how does physics report collisions? If not having the entities be the actor of the actor model, each passing a storm of messages around the system of ECS. The system of ECS being the one gathering up what needs to be sent and instead doing the one doing so. Yeah, that's what I'm currently leaning towards, is an actor model where the actors are systems. And the data that the systems act upon are entities. And that's kind of like instead of relying on the current state of, yeah, 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 actors are systems, but okay. Instead of it being systems, it's not entity component systems. It's the entity actor model. So instead of entities, of a one-to-one mapping of entity to actor in Brane, actors will be per component. Actors will just be singletons or chunk level objects. I think I like the idea of actors being chunk level objects. So actors are not singletons. Actors will be chunk level singletons that may only mutate the data of entities they have explicitly been given access to and must interact with may only directly mutate the data of entities they have been explicitly been given access to. But to mutate, to allow for encapsulated, but they may indirectly mutate the state of certain entities by queuing and waiting on actions performed by other actors. So, if you want to say move an object, you would have to See, the thing is, I think interfaces are entity level things. Because I'm also thinking about stuff like, let's say you have an object and you want to teleport it. And that object may or may not be interacting with the physics system. If you have a physics system, teleporting versus moving an object are two different things. Because teleport is instantaneous, whereas movement, it moves through your scene. So I'm wondering, like, do I want to preemptively create an abstraction for not being able to directly set the transform of objects, but instead sending a message to either move an object or teleport it or apply forces to it, like, may only directly mutate the data of entities. I meant to say components there, but entities might be the play. Entities and components. Here's the thing. If I have a physics object, maybe that physics object, if it has a position, maybe it shouldn't store that position outside of the physics system. Or something like that. Or if I queue up a movement action on that entity, I don't know, I'm just thinking of like the very specific case of moving physics objects through their transforms, or like even do I want to expose the ability for actors to directly move entities? Is that actually something I want to do? Because if I'm thinking about it, user generated code, right? So if I have one chunk, and let's just say the chunk is also utilizing the actor model, and different chunks are different actors. And I have a chunk from one author sitting right next to the a chunk from another actor. Or let's say we have a I think an avatar is a better example for this. An actor is essentially a special form of a chunk. It's if we describe chunk as a unit of like essentially like a prefab almost. I guess not actors. I guess avatars would be their own little encapsulated thing. I'm just thinking about the permissions of. I don't think we want to directly expose the direct transform of basically anything to anything. Um, and that basically needs to be a. If we edit the transform of an object, that basically needs to be like a request to the object to be able to move it, as opposed to just like directly setting the position of an object. I'm not even sure that Brane has a scene graph. Brain Engine might just straight up not have a scene graph. So I might walk it back to if we do have a scene graph, it's frames of reference as opposed to like objects. Um, reference frames. Because that's what a chunk is. A chunk is a reference frame, and then that chunk has a relative position to other reference frames. And then avatars and like a user's play space is another reference frame relative to whatever its parent reference frame is. If you think about a vehicle, that is also a reference frame um, relative to a chunk. So we basically need to decide what scope of authority different actions or mutations on data have. Okay, I'm gonna have to think about this a lot more of where does our data live and where does it get passed around? Because like right now I'm just like completely losing the concept of like game objects are very structured. They're very easy to wrap your head around because you're just like there's this thing and it exists at this point in space, and or even entities are very like structured. There's this thing. It can exist at this point in space. Like here are all the properties that this entity has, but what I'm kind of like coming up with in my mind here is different actors are like different forces of nature and they interact with each other, and at the end result you have data that essentially is like a description of how to draw a scene. And that is very unstructured, and I don't know if anybody has any way to like work through that's not in a very that isn't a very intuitive way to work with stuff at all. It makes intuitive sense in the data format way, but it doesn't make a lot of sense in the ask a aspiring developer to learn how the system works way. It's like how anime involving virtual worlds sometimes has a character being an avatar of some aspect of the game system. Kind of, except they wouldn't be conscious or personified. They're just a thing that acts, that can do things. Okay, and now I'm mentally getting to the point where creating what certain objects are or what certain actors are almost becomes a like you'd have to make a node graph, have a node graph right next to the inspector to set up um your entities, because kind of what I'm imagining is like let's say you have an IK system and let's say you have an IK inverse kinematic system. Now, what input data do you need for an inverse kinematic system? And actually, inverse kinematics is a great example of where the when you're dealing with IK systems, when you grab the transform of an object is very important. So there are many points in time at which you could grab the transform of a particular object. So you have the initial mesh T-pose. So this is like the default state of all the bones of a mesh. And then you have an animation system, and the animation system references its own animated version of the transformation of this object, and then it lerps and it does a bunch of transformations. It takes into account like the current time in the editor, and then it has like an output of like, oh, these are transforms, and it tries to map those onto the object. Then if you have an IK system, it would take the output of the animator and then do transformations on the output of the animator. And then after all of those transformations are done, that's when you would get the output, which is the potential final position of that object. Now, what if you also have something like a physics system, like Fizzbones or whatnot? Then you would need to run like any physics simulations you need that are dependent upon the positions of things in space. So you have like within a single frame, you have like this thing must happen, this thing, then this thing must happen, then that thing, and you need all of those to be ordered in a very specific way. And thinking about it, they don't necessarily need to be components on a game object. In fact, it might be detrimental for them to be components on a game object because you can't really dictate the order of operations of components on a game object. And in that situation, you very much need to care about the order that things happen on that game object. Now, think about it. IK could be thought of as a system of predefined operations that happen to an object. So you could almost think about adding components to a game object as a form of scripting. You both define the state and the scripting at the same time, but you're not really able to do the transformations. So I'm kind of reinventing Unreal blueprints to a certain extent, where we have an actor. I want to compose the actor through composition. I don't want to compose an actor through I don't want to compose an actor through, work with me here, Brane. I don't want to compose it through inheritance. Despise inheritance. But I do like the idea of having building blocks upon which you construct a thing that works a certain way. Like procedural generation? Almost. Almost. Because when you're setting up the okay. Is this it? No. Actually, I think this is it. Because a while back, Malik sent me a. There's a certain thing. Ron is a common choice. Where is SCN? Not GLTF blueprints. Thinking of something like that Pixar, or was it Weta way of describing a scene? I'm not sure, but there is a thing that Bevy has for storing assets. I think it might be Ron, might be common assets. He might be Ron. Are there examples here? Examples. Level.ron. So we want to look at level.ron. Okay, so it's just a scene description. Basically, there was a Bevy scene description that was a script rather than an actual like rather than like just a serialization format. It was literally like a simplified Rust script. So let me see, where's this dude? There you are. BSN. BSN, is it? Searching Bevy in my message history of this guy and scrolling down a lot. Okay. Okay. So here's our BSN macro. BSN macro returns an entity patch tree. This makes it interoperable with patch, dynamic patch, scene system. Relies on construct. So want to see file. What does a BSN file look like? Because BSN, to my understanding, BSN asset files have no direct tie to a version of a crate defining a type. This can easily cause compatibility issues, so sprite image was called sprite texture. Okay, so this is how you say a specific... Hmm. But you see how, like, this use statement, this is inside the serialized format of this, not in the, this isn't code, this is a serialized scene. So let me get a more advanced version of this, because it's looking simpler than I remember. Okay, it looks like it is just a tree, as opposed to an actual script that runs. Okay. So BSN isn't actually a full like tiny scripting language, though I do believe it supports multiple inheritance. Or can it? Here. Does it have entity references syntax? Like entity path? Oh, it looks like it doesn't have a thing for references. Okay, this is a lot less developed than I thought it actually was. Okay, so I can stop having this hallucination of something that is not as good as I thought it was. Actually. Okay. So basically, I think I think I'm gonna have to think more about this off stream, and I'm about getting to the point where like my voice is entirely cooked right now, so it's getting a little late. So I think I'm gonna end stream here since I'm kind of just sitting here in silence considering this, and then I'm gonna think about it more. Like, are we gonna go total like Unreal Engine inherited classes? Thing can't really be changed once it's constructed, or are we gonna go the other method of more entity component system? And I kind of think is going to be a something to the tune of actors can't be reconfigured by external things, but actors can internally restructure themselves or something weird like that. Basically, I don't want there to be a concept of a class. Like classes of things. I do like interfaces for opaque objects, but I don't want those objects to specifically be of types. Now, we could do like an interface that is a collection of interfaces, which I guess is like a class of thing, but I don't want to specify what's contained by that thing. Which is generally what a class does. Like, the internal structure of this thing must match this class. But the problem is I don't know how to represent things that exist in the scene using this system. Straight up not sure how to do that. Unless I pass around interfaces instead of direct data for stuff. Anyway, I'm gonna have to think more about this because I am nuking my brain. Um, but yeah, thank you to those who were listening to my mad ramblings for this entire time. Oh, universal scene descriptions. No, if I go with any universal screen description, it's going to be GLTF most likely. But yeah, I'm gonna go wander around outside at 10:30 and think about stuff or go for a run. I might go for a run. But yeah. All right. See you around. Thank you for those who stuck around, and I will see you.